Well, let's take a look at this chapter. This is control structures part 2, repetition. So let's get it working. There it goes. In this chapter, you will learn about repetition, looping control structures, learn how to use a while loop in a program, explore how to construct and use counter-controlled, sentinel-controlled, fly-controlled, and end-of-file controlled repetition structures, learn how to use a for loop in a program, and learn how to use a do-while loop in a program. Examine break and continue statements. Discover how to form and use nested control structures, learn how to avoid bugs by avoiding patches, and learn how to debug loops. Why is repetition needed? Repetition allows efficient use of variables. For example, if I'm going to read in 20 numbers and average them, I could declare 20 variables, num1, num2, all the way up to num20, then add them together. But through a loop, we can just bring them in one at a time, add it to a sum, and then at the end divide it by our total count. So again, it's the efficient use of variables. It is possible to input, add, and average multiple numbers using a limited number of variables. Okay, I already talked about that. Consider the code to determine the average number of calories burned each day during regular exercise. And method 1, declare a variable for each day, and then do all the calculation. Or method 2 is create a loop that reads it in and sums it and then divides by the count. A while loop is one of 3 repetition or looping structures in C++. Syntax of the while statement: while, then you got your beginning parentheses, expression, closing parentheses, and then your statements. Usually, if you got one statement, you can just put a single statement. If you got multiple statements, you put a curly braces around your statements. The expression is a Boolean expression. For like while sales is greater than 100, while count is not equal to a value, so on. Okay, statement could be simple or compound. Compound means you got multiple. Expression acts as a decision maker, is usually a logical expression, Boolean, true or false. Statement is called the body of the loop. And the parentheses are part of the syntax. Here's the idea behind a while loop. Checks the expression. If it's true, it does the statement or statements, and then repeats and checks the expression. If it's still true, it does the statements, and then just keeps going. When the expression is false, that means it drops out of the while. Expression provides an entry condition to the loop. The statement, body of the loop, continues to execute until expression is no longer true. And if in the loop continues to execute endlessly. Okay. Now here, we got int I equals 0. Let me comment this out. I think there's a way to comment it out up here. Maybe not. Edit. Comment. There we go. So, to begin with, we're declaring an integer called I, and we're setting it equal to 0. While I is less than or equal to 20, and we're going to do a cout I, then a space, and increase it by 5. And then out here we'll do our end line. Okay, so to begin with, I is equal to 0. Comes down here, it checks to see if I is less than or equal to 20. Well, 0 is less than or equal to 20, so it'll do these lines of code. And this simply will print out I, which is 0 at this point, with a space, and increase I by 5. It'll plug 0 in here. 0 plus 5 is 5, so reassigns the value of I to 5. Comes up, drops down to this curly brace, comes up here, and then checks this condition again. I is now equal to 5, and 5 is less than or equal to 20. So it goes through this again. Prints out 5 in a space. And then it plugs in 5 down here. 5 plus 5 is 10. Assigns it back to I, comes back up here and checks it. So it's sitting here looping it. Now what this should do is print off 0, 5, 10, 15, 20. Let's run this and see. 0, 5, 10, 15, 20. Variable I in example 5.1 is called a loop control variable. They got names for everything. It's not that important. It's real important. You need to know how to do a while statement, a while loop. Now this one is starting at 20, and while I is less than 20. Well, to begin with, I is not less than 20. So right from the very beginning, this Boolean is false. So it comes out here and just prints the next line. When you know exactly how many times a statement needs to be executed, use a counter-controlled while loop. And you see you got counter is equal to 0, you got while statement, and counter plus plus. Example this. Let's say I want to add all the numbers from 1 to 100. Well, I need a integer, so that's good. Then I'll refer to it as sum, since I'm going to add them together. To begin with, setting it equals 0 is fine. Now I also need to keep track of index. The index would keep track of what numbers we're going through, 1, 2, 3, all the way up to 100. Now I want to continue while the index, and you can call it whatever you want. You can call it I like they did in that previous example. I want to continue while index is less than or equal to 100. And then down here, I'm going to say sum is equal to sum plus index. And then I want to increase index by 1. So index is equal to index plus 1. And then when that's all said and done, I want to print out my sum. The sum is sum. Now let's run this, make sure it works, and I'll explain what I'm doing. Sum is 5,050. Well, initially the sum is what keeps track of our sum of numbers. The index is what we're increasing it by. That's what they're referring to. And I'll check while index is less than or equal to 100. It is initially because it's just equal to 1. Comes down here, it takes the old value of sum, which is 0, and adds 1 to it. 0 plus 1 is 1. And then increases index by 1. So then it comes out back up here. Index is now 2. It checks to see if 2 is less than or equal to 100, which it is. It then takes the old value of sum, which is 1, and adds the index, which is 2. 1 plus 2 is 3, and puts that value in the sum. And then continues that same pattern. Now instead of index equals index plus 1, you can do index plus plus. That's kind of a short way to do that same notation. It's up to you whether you want to do that or not. Personally, I like index equals index plus 1. I think it's easier to read, and for me, that's a main goal of a lot of programming. Okay, and that's just talking about updating the loop control variable. Okay, Sentinel variables tested in the condition. Loop ends when a Sentinel is encountered. Don't think that Sentinel means anything special. It's just variables we're working with. Okay, the following is an example of a Sentinel-controlled while loop. And so initially, we're going to bring in a variable from the user. While a variable is not equal to the Sentinel, then well, that's not very good. A little bit of an error there. That variable that was on that line should have been part of the comment. Test the loop control variable. It's not on a separate line. Makes it look like it's a command. Your code would not work right if it did that. Okay, then we got doing whatever here, and then we get in another variable. So it's going to continue until some kind of condition's met. Well, let's see what in the world that means. Okay, we're going to add all numbers from 1 to something. Add all the positive numbers. And when I say positive numbers, I'm talking about integers. From 1 to something. Okay, so I'm going to have a C out here, and I'll say input numbers until done, -1 to quit. Okay, input numbers until done, pressing enter after each one. Pressing enter after each one. Well, again, I want to have a sum. So I'm going to have int sum is equal to 0. And then I'm going to bring in, I guess I need a variable, don't I? They call it variable. But let me choose num. There we go. And bringing that in for num. While num is not equal to -1, then sum is going to equal to sum plus number. And I'm going to read the next number. Then down here, print sum. Okay, all that's still good. Let's run it. Not that vast. Go ahead and just get out of that one. Okay, input numbers till done, pressing enter after each one. So put in 3, 5. That should add up to 8. 3 plus 5 is 8. 2, that's 10. 4 is 14. -1. And you see it says sum is 14. Now let's examine this a little bit closer. We obviously prompt them for that. I set sum equal to 0 initially because I haven't added any numbers yet. And I have to have them input a number. That's what we're declaring as variable num. And then that's our cn. We redirect to the num. Then we check to see if num, make sure it's not equal to -1. If it's equal to -1, we want to drop out of the while loop and do the code down here. So just as long as I don't input -1, I can keep doing the same code over and over. And this just adds them together and then asks for the new number. So that's our Sentinel controlled while loop. And talked about example 5.5, which I'm assuming is the next one. Program converts uppercase letters as a corresponding telephone digit. Sentinel value is £. Excuse me. No, that isn't the next example. Must be referring to the book. Case 3, flag controlled while loops. So you create a Boolean. They don't show it declared here, but you do bool is found is how you declare it. Like that. I think it's lowercase b. Let me double check. Okay, if I'm up here, bool. Yeah, it is lowercase. Is found. Like that. Okay, Boolean is true or false. Initially, it sets it equal to false. Then, it's checking while this is a not, is found. So while not and is found is false, so while not false, it's going through and doing this. Once a condition is met, you manually set is found equal to true, and that drops you out of the loop. Okay, let's talk about another example that's in the book. Let me grab a drink here. Okay. End of file. Controlled while loop is a good choice when it's difficult to select a Sentinel value. Logical value returned by CN can determine if there's no more input. Following code uses an end of file controlled while loop to find a sum of a set of numbers. And that looks like one we just already did. But the function end of file can determine end of file status. That's where this is additional. End of file is a member of the data type iStream. Syntax for the function end of file is isstream var.eof, and then our beginning parentheses, closing parentheses. And iStream var is an input stream variable such as cn. I don't think they have one example here, but if you look in the book, you'll see an example of that. That's where you're reading in a file. So you got a file. How many numbers do you have in a file? Lines, if you think about one number per line. Well, you could have 50, you could have 5,000, you could have 1 million lines. You don't know. So you just keep going until you're done. Now, the expression in a while statement could be complex. So, and this is an example. While number of guesses is less than 5, and then and not is guessed. So the is guessed is Boolean, and that says not true or not false or whatever you set that equal to initially. Now here's considering following sequence of numbers 1, 1, 2, 3, 5, 8, 13, 21, 34, called the Fibonacci sequence. Given the first two numbers of the sequence, A1 and A2, the nth number, a sub n, where n is greater than or equal to 3 of the sequence, is given by a sub n is equal to a sub n minus 1 plus a sub n minus 2. And so A1's 1, A2's 1. Then you determine the third number. Yeah, they don't really say it, do they? Determine the nth number. That's just the idea. But what you would do is, if you notice here, it just adds them together. It's 1 plus 1 is 2. So this 2 right here is 1 plus 1. This 3 right here is 1 plus 2, which gives us 3. This 5 right here is 2 plus 3. This 8 is 3 plus 5. This 13 is 5 plus 8, 13. This 21 is 8 plus 13, 21. And this 34 is 13 plus 21, or 34. So that's what they're saying. This shows it. If A2 is equal to 6 and A1 is equal to 3, then A sub 3 is going to equal to 6 plus 3. Add the previous two numbers. It gives you 9. This one, A4 is equal to A3 plus A2. A3 was 9, and A2 is 6. 9 plus 6 is 15. And then it says, write a program that determines the nth Fibonacci number given the first two numbers. First thing we'll do, input the two Fibonacci numbers and the desired Fibonacci number. Hopefully I'm pronouncing this individual's name correct. Output the nth Fibonacci number. Algorithm, you get the first two numbers. You get the desired Fibonacci number, get the position in of the number in the sequence. Calculate the next Fibonacci number, add the previous two elements of the sequence. Repeat step 3 until the nth Fibonacci number is found, and then output the nth Fibonacci number. Sometimes their algorithms are a little bit left to be desired. Let's see. int a1 is equal to 1. int a2 is equal to 1. That's by default. Now I shouldn't say a1. I should say first a. I should say second a. That's just the numbers we're working with. And then I want to get which Fibonacci number they want. So which num? Then I'll say cout. Which Fibonacci number do you want? And we'll bring in which number. And has to be greater than or equal to 3, I should say. N is greater than or equal to 3. Now our index is currently, I need to declare index. And our index is currently at 3, let's say. Now I'm going to have a sum too. This is really, that's what you're doing, is you're adding these together. I'm going to continue while the index is less than or equal to. Now, I never have programmed this, so it may take me a little bit to get this. Is less than or equal to which number? And I'm going to increase index by 1. Okay, so if they enter in 5, it starts at 3. So there goes 3, 4, 5. So then our sum is going to equal to our first A plus our second A. Okay, so if they enter in n equals 3, our first A, okay, no, I don't want to do that one. N is equal to 4. Our first A is equal to 1. Our second A is equal to 1. What this will do is it'll add those together. So sum is going to equal to 1 plus 1, or 2. So then we want to shift our numbers. So we want to take the value that's in second A and put it into our first A. And then we want to take this 2 and put it in here into the second A. So first A is going to equal to second A. And second A is going to equal to sum. Okay, I'm going to get rid of this. I think that's all I need, but we'll see if it works. So the answer is What am my answer going to be? Second A, I guess. I guess I could actually refer to sum too, but I think that should do it. Well, no, if we run it, our Fibonacci sequence should look like that. So if I put in 3, I should get 2. If I put 4, I should be getting 3. If I put 5, 5. 6 is 8, 7, 8, 9, so forth. So let's run it. Build. Okay, so I'll put 3 in. The answer's 2. Doesn't mean it's working. Let's run it again, and let's put 6 in. 8. Is that correct? 8. Let's see. 1, 2, 3, 4, 5, 6, 8. So 7, 8. Let's put 9 in. That should give us 34. The answer is 34. Now, don't get too stressed out about this. Don't think, well, I've never had mathematics that require me to know what in the world a Fibonacci number is. 13 years of programming. If you program in manufacturing, finance, purchasing, sales, applications, you'll find the hardest math you'll do is calculating the average. Now, if you go into the scientific field, then this is more, you should be able to wrap your mind around the algorithm on this. Okay. Probably my code looks nothing like theirs. They might do a very clean version of it. Okay, and they're going through a bunch of else ifs. Oh, I didn't check to see if they put 1 or 2 in. I assumed you had to be 3 or greater. They refer to a previous 1 and previous 2, and my sum was their current, but same idea. Now we got a for loop. For loop called a counter or index for loop. Syntax of the for statement. We got a for, beginning parentheses, initial statement. This is where you're setting the variable equal to an initial value. I is equal to 0 type example. You got your loop condition, that's your Boolean. You're going to continue what I is less than or equal to 100, let's say. And then your update statement, this is what you increase I by. It could be I plus plus, or you have a different statement altogether. And then if you have one statement, you don't need the curly braces. If you have multiple statements, you need curly braces around it. Let's see what in the world we're talking about with the for loop. I'll go back to my example of adding all the numbers from 1 to 100. So I'll have a for, and I'm not sure if I need the int there or not. I think I do. Some programming languages require it. You tell it the variable type. And some you have to put it outside of it. So int x equals 0, continue while x is less than or equal to 100. That's our, how long do we continue this for loop? And then x equals x plus 1. Again, you could have, instead of doing x equals x plus 1, did x plus plus. I like this because it shows that it can be anything. You could increase it by 5, by 10. It's not just by ones. And then I'll say sum is equal to sum plus x. Now I do my cout. The sum is sum indel. So if I run this, $5,050. What we'd expect. Okay, let's examine what in the world is going on here. Oh, wait, I can increase this by 1. And now do a debug or build and run. You see we get the same thing. So I didn't have started at 0. Okay, let's examine what this is doing. Sum is equal to 0, of course. Initially, it sets x equal to 1. It checks x is less than or equal to 100, so it's going to do the for loop. So it goes through here and adds those together. So you got your sum, which is 0, plus 1, gives us 1, and assigns it to sum. And then increases by x by 1. So x is now equal to 2. It checks to see that this is less than or equal to 100, which it is. And so then we'll take the value of sum, which was 1, add 2, and 1 plus 2 gives us 3, and assigns it to sum. And then this increases it by 1. So again, that increases it by 1 each time. Now, let's do another see out here. Let's see what in the world the value of x is. Okay, so I'm going to do a build and run. I got some kind of error. What does it like? Doesn't like it outside of the for loop because I got it declared just within the for loop. Okay. This should be interesting. Okay, so I'm going to run this. And instead of 100, let me change it to 10. Otherwise, I'm just going to have too much on the screen. Okay, build and run. Value of x is 1 through 10. Notice it never reaches 11 on that. When it comes down to my last value, well, first off, it sets x is equal to 9, 9 plus 1 is 10. It goes ahead and does the loop again because it's less than or equal to 10. But then it increments x again. So it increments it after it's done. And you got 10 plus 1 is 11. And then it comes up here and checks again. And it's not less than or equal to 10 anymore. So it drops out and does this see out. It's important to know what happens here. When does it increase x? Does it increase it before the loop or after the loop's done? It's after the loop. Okay. And this shows initial statement. You got your loop condition, checking if it's true. If it's true, you do statements, and then you update that statement. That's where you increase it by 1. Like I say, that's done after the loop is done, or after the statements are done, I should say. Let's see. Let's just talking. I already talked about this. Following for loop outputs hello and a star on separate lines 5 times. So it gives you an example. Not a useful example. Consider the following for loop. What in the world is this doing? Hello and next line. Okay, that's what that one was doing. I may be missing something. Let me double check it again. Y++, C out. Oh, there's no curly braces around this one. So this one down here, what it does is, since there's no curly braces, it only does this one line of code for the for loop. This last indel is only done once, not five times, as the loop would indicate. Following is a semantic error. Can't have a semicolon after your for loop. I don't know how many times I've messed that up. That'll cause you more headaches to your sitting there trying to figure out what's going on. If I put a semicolon right there, and I go to run it. Assuming I hadn't been accessing X here, what we'd see is that this would basically loop through doing nothing. You never want the semicolon there, so that never should be there. Same with the while. If you have a while, if you have a while and then whatever it might be, x is less than or equal to 100, you never want a semicolon there. It'll cause you more headaches. Some cases you'll find that if it's after a while, it'll run forever. That's what they're talking about here with an infinite loop. That's interesting. I never tried that. 4 and then leave them all blank. Huh. You can count backwards using a for loop. So a for loop and a while loop both give you total control. While has a little bit more, but instead of x equals x plus 1, you say x equals x minus 1. Now your condition, Boolean condition, has to meet that. In this case, I probably need to start at 10. And I want to continue while x is greater than or equal to 0. So it starts at 10, and this x equals x minus 1 will reduce it by 1 each time. So go to 9, 8, 7, 6, 5, 4, 3, 2, 1, and then 0. It'll continue while x is greater than or equal to 0. So when it goes to negative 1, that's when it'll drop out of the loop altogether. Grab another drink. This is what I'm talking about. You don't have to increase by 1s, you increase by 2s or whatever. Increasing by 2s might allow you to add odd numbers or even numbers, or just print them. Now I don't use this DoWhile. I've been 13 years of programming full time, and programming since 1989. I've never had to use a DoWhile. I've always been able to program everything with just a normal while loop. Some people like it. If you like it, then that's fine. The benefit of this is you always do one pass before you do your check. So if you have an application where you want to make sure you do one pass before you then check it, that's when you'd use this. But again, I've always been able to write a while loop, handle every case this would encounter. Statement can be simple or compound. Loop always iterates at least once. And here's our idea. It comes down here, does the statement or statements, then does the check. If it's true, it comes back up here and runs more statements. If it's false, then it drops the next line of code. There shows you an example. Like I said, I'm not big on that, so I'm not going to spend any time on it. While and for are pre-test. DoWhile is post-test. Pre means you check it before you do the lines of code. Post means you check it after you do at least one line of code. And this shows you. I think that demonstrating you can do the same thing with both the loops. So, okay, choosing the right looping structure. All 3 loops have their place in C++. That's a matter of opinion. I don't like the DoWhile. You can determine in advance number of repetitions needed. The for loop is the correct choice. If you do not know and cannot determine in advance number of repetitions needed, and it could be 0, use a while loop. If you do not know and cannot determine in advance number of repetitions needed, and it's at least once, use a DoWhile loop. I like to keep it simple. I consider there's only 2 looping constructs, the for and the while. Break and continue alter the flow of control. Really don't like these too well. Break statement is used for 2 purposes: to exit early from a loop and to skip the remainder of a switch structure. After break executes, the program continues the first statement after the structure, and a break statement in a loop can determine the use of certain flag variables. I don't even think I know the syntax for it, to be honest. Let's say I'm going to I have a while statement here. While x is greater than or equal to 100, x is equal to 200. And then I'm going to see out x. And space, I guess that's it. Okay, if I run this, probably hang up my machine. Hopefully it would exit gracefully. But this, what this does is it's an infinite loop. While x is greater than or equal to 100, 200 is greater than or equal to 100. And I never increase, decrease, or do anything with x. So x will always equal 200. So this will never drop out of this loop. I can see a case where if you got a condition that you're not sure it will actually ever be met, then you could put an if statement in here. You know, you're programming it, and if you're pretty sure it should never equal without, or maybe it doesn't increase. Maybe I have index in here. Index is equal to 0. And within this, I'm going to increase index. Now you know that there's a problem if it's gone 1,000 times. So I can say if index is greater than 1,000, or greater than or equal to, or whatever, then you do a break. I'm out. Okay. Debug, build and run. Not declared. Let's try that again. Probably X wasn't declared either. Okay. Build and run. Okay, so I scroll up, I got a lot of 200s. And then it comes down here and says I'm out. So it just keeps on, like I say, it's an infinite loop, just keeps going on forever. But then I have a check in here and say, hey, if I've done this 1,000 times, something's wrong. Let me go ahead and break out of this. And what that does is breaks out of the while loop and then throws you down to this next line. So that's what a break does. I've never used break either. I know what it's for, I know its purpose and so forth. But again, proper programming is such that you shouldn't need to use a break. If you've programmed your while or for loop correctly, you've programmed it to exit the way it should. Continues using the while, for, and so forth. When executing the loop, it skips remaining statements and proceeds to the next iteration of the loop. I could see this one probably more. If you want to exclude 10 numbers, for example, you could use the continue to help exclude those 10. But yet it'll still do all the other ones. Although a proper use of an if statement will do the same thing. Okay, you can nest them. So you can put one for loop and another for loop. This will become a lot more important once we get to arrays. When we talk about arrays, you have to have a nested loop in some form to properly go through them. And this will probably just print so many rows and so many columns of asterisks, if I had to guess. Oh, there, create a following pattern. Helps actually read. Here it talks about starting with 5, continue while it's greater than or equal to 1, and then reduce it by 1. And then it gives you the answer. What will happen? Avoiding bugs by avoiding patches. Software patch is a piece of code written on top of an existing piece of code intended to fix a bug in the original code. Some programmers address the symptom of the problem by adding a software patch. A programmer should help instead resolve the underlying issue. This is probably debatable whether to avoid patches or not. I tend not to like to be the first one to try anything out. I think it's best to program around a bug that's in a system instead of trying to introduce other ones. Went to the doctor and he told me there's a new shingles shot out, and he recommended it. Well, right away in my mind, I'm thinking, okay, I'm not going to be a guinea pig on version 1. You know, let it go for a couple years. Let a bunch of other people have the headaches of medical issues and so forth, and then I'll think about getting that shot. Because again, it's never good to be the first one to receive a patch or anything brand new. Debugging loops. Loops are harder to debug than sequence and selection statements. You can use a loop invariant, set of statements that remain true each time the loop body is executed. Most common error associated with loops is off by 1. There's a review. I'm not going to go over that. We know we just covered. What they mean by that is if I'm looping through, and I'm going to add all the numbers from 1 to 1,000. So I got sum is equal to 0, index is equal to 1. I want to continue while index is less than or equal to less than 1,000. And then what do I say? Sum is equal to sum plus index, like that. And I do a C out. The sum is sum indel. Okay, so I do a debug, build and run. Did I increase it by 1, or did I just write an infinite loop? It's not finishing. Okay. Wrote an infinite loop. I didn't mean to. But I did increase index by 1. Okay, that wasn't on purpose. That was just bad programming. Okay, build and run. Is that right? I don't know. Let's say it's not right. I have some way to determine whether it's right or not. Well, if I put a C out in here, index, if I run this, whoa. This one's maybe not too bad. Can it even go up that far? Oh, it does go back up to 1. I don't even know where I'm at, but somewhere in there is the numbers. There we go. This one I can kind of see because it stops at 999, doesn't go to 1,000. But when you got a loop, and if you try to put a C out in there, it could be so much is printed to the screen you can't tell what's going on. So you have to use clever ways. Maybe I don't print out unless the index is greater than 950. So if index is greater than 900 and let's say 90, then that's when we'll print out. Because that's where I think the problem is at the very end. Do a debug or build and run. Okay, then maybe I can see it a little bit better. So what they're saying is it's hard when you got a for loop and you're going through many times for you to sometimes be able to debug what's going on with that. Using little tricks like that can help you. And that's the end of the chapter, so I'll go ahead and stop the recording.